All right, geometry. This is going to be one of those test the waters day. It's not going to be heavy on the note taking. In fact, I'll tell you what to take notes on. I'll point my finger to it and say this part's important because I'm going to use a lot of personal experience about what proofs are and how I even struggled with it. And yeah, so this part in particular, this is stuff that you should take notes on, like this above part right here. So what is a mathematical proof? Well, a mathematical proof is a mathematical statement that typically involves a hypothesis, axioms, theorems, and a conclusion. In other words, it's kind of like a science experiment. Math and science go hand in hand, right? It's like proving an argument. In fact, it's one of the life skills of what we use in math is that math is not just numbers and variables. It's actually a branch of philosophy. Philosophy is the study of arguing, study of persuasion, questioning things. And science is what we do with experimentation. Mathematical proofs are what we use with numbers and variables to prove true statements. And remember, a hypothesis, go back to science, is just an idea. An idea. And you can't just spit out ideas without proof, without evidence. And so you need axioms and theorems to reach your conclusion, right? So for now, just know that axioms and theorems is basically logic. So how do you use logic to prove your hypothesis? We're not going to be mixing, stuff in beakers or using Bunsen burners or anything like that. But we're basically doing the same thing. We're proving our hypothesis. So let's just think about like some life skills. You don't have to take notes on this part. So let's just think about life skills. Like when would you ever use a proof? Well, truth be told, when I was in college, I wasn't always going to be a math major. In fact, for the longest time, I was a kinesiology major, which, if you really want to know, it's biology and sports, like physical therapy, an athletic trainer, a dietitian, and so on and so forth. Like how to use biology to be a better athlete. But in other words, I'm getting off topic. Life skills. So, like for instance, an English or a social studies persuasive essay. I was never really good at this. I was never really good at saying, why is Atticus Finch the central character? Why is Scout Finch the central character to Kill a Mockingbird? Or, for instance, if you want to get political, should we have Columbus Day? Is something that you can use in a persuasive essay, like in either argument. Should Columbus Day be celebrated? Well, you have to use logic. You have to use evidence as to how successful the man was and how morally corrupt he could have been back in the day. In other words, political debates. You use proofs all the time. You use evidence. You use a goal. You use a conclusion. But you use the evidence that's given to you to prove, is capital punishment constitutional? Should we have socialized medicine? And or just being a lawyer in general. You can't just go to a courtroom and say, ladies and gentlemen of the jury, my client is innocent. Have a good day. No, you can't just say that. You have to provide evidence. Being a police officer, conversation in general. In fact, I was trying to think of something that wasn't controversial, and this conversation legitimately happened last year. So, as you guys know, I'm a huge baseball fan, and a friend of mine noticed my Cleveland Indians cap. And he's like, first off, he questioned, like, I always talk about the San Francisco Giants. I'm a huge fan, and yet I'm wearing a Cleveland Indians hat. And he asked me, have you ever been to Cleveland? And I said, I've actually never even been to Ohio. And that was the conversation that was the statement that just came to mind. He asked me, have you been to Cleveland? And I said, I've never even been to Ohio. And he said, you didn't answer my question. And I was I was like, yeah, I actually did, because I showed him this diagram. Like, we have a city's in a state is in a country. So if I say I've never been, and you ask me if I've never been to Cleveland, and I respond, well, I've never been to Ohio, not only does that disqualify I've never been to Cleveland, I've never been to Cincinnati, I've never been to Cleveland, I've never been to Columbus, I've never been to Youngstown, Ohio, I've never been to Ohio. And yeah, I shouldn't have said that. But you see, I used mathematical proof to answer the question. I've never been to Cleveland. No, I haven't even been to the state where Cleveland is located. But please just be kind to your friends. That's all I'm trying to say. Is anyway. So let's turn. So in the spring of 2010, I actually changed my major from kinesiology to a double major into mathematics and liberal studies. And in the spring of 2010, I was pumped. I took calculus. I'm like, what's a math major? Is it just more of plugging in for x, solving for x? Oh, I could dominate this stuff. I could do word problems. I could do this. But it turns out that if you want to major in math, if you want to get a bachelor's degree in mathematics, you will be lucky to ever see a number ever again in your life. Everything is variables. Everything is Greek letters. And in fact, you're not doing math problems, you're doing math proofs. You're literally a lawyer proving an argument. You're literally a political debater proving an argument. And it was just unbelievable that I literally chose math as a major because I was not good at writing papers. I was not good at the essays in social studies and English class, and here I am. I have to do that with math. You literally have to write papers in using variables and proofs and axioms and theorems for math class. I'm not making this up. So if you've ever thought about majoring in math, be prepared for what's in store. So you don't have to take notes on this part, but you should take notes on this below part. So I just want to clarify, because when I was a college student, I couldn't understand the difference between an axiom and a theorem. An axiom is a statement that is taken to be true. In other words, we got to start somewhere, right? Like if we just question why on every single detail, some things just can't be explained. Like, for instance, why is the alphabet in that order? Why does it go A, B, C, D, E, F, G, and so on and so forth? Why do we choose 26 letters? It is what it is. Why do the whole numbers go 0, 1, 2, 3, 4, 5, 6, 7, and so on and so forth? It is what it is. Why is this color black, this color green, this color red? Why is this color yellow? It is what it is. So, in other words, a simple definition for an axiom is it is what it is. Just is. We have to start somewhere. Now, a theorem is a statement that is proven from previous true statements. So, for example, I just drew these little stick figures. Jim is taller than Sarah. Sarah is taller than Greg. How do you know that Jim is taller than Greg? Well, if Jim is taller than Sarah and Sarah is taller than Greg, then Jim has to be taller than Greg. That's called the transitive property. So you just use deductive reasoning. Okay, if one's bigger than the other, and the second one is bigger than the third, well, the first has to be bigger than the third then. Okay, so yeah, that's the important part, is knowing the difference between it is what it is and this can be proven. I can use previous knowledge to prove it. Okay, so the main idea, let me just get that right here. So the main idea, this is a note-taking part right here. So the main idea of a mathematical proof is you always state what information that you are given, always. Even if it's completely obvious to you, always state what you were given. Then, from that given information, what previous information can guide you through the given information to get out of this maze. Like if you've ever done a kids menu at a restaurant, they give you a maze. You've got a start and you've got an end point. How do I get from the start of the maze to the end of the maze? Be thorough to get to your conclusion. And hint, as I learned the hard way in college, doing an example, like one or two examples, that's not a proof. That just listing, that works, so therefore it always works. So, for instance, let's just say I give you 3 questions, and again, this is geometry class, but I'm just going to show you like what an easy kind of proof is. in college, and I'm gonna do this intentionally wrong. Okay, so just show this. I'm gonna do this intentionally wrong. So something that you guys can think about and you go, huh, that is true. So if you take an even number plus an even number, you will get an even number. So when I was in college, me and this other classmate, we were actually really good friends, and we just went, well, I don't know, we'll just come up with even numbers. Let's go with 12 plus 18. 12 is even. 18 is even. Well, that's going to be 30. Huh, 30 is even. Oh, that works. And then our professor's like, not good enough. And I was like, okay, all right, well, how about 60 plus 22? 60 plus 22 is 82. Huh? That's another example. And the professor's like, not good enough. I was like, well, I have no idea what you want then. So we did the same thing. We did odd number plus odd number is even number. So again, I just want to make it clear. This is even though the examples are true, this is the wrong way to do it. So odd number plus odd number is even number. Okay. Let's go with 7 plus 5. 7 plus 5, odd plus odd is 12. That's going to be even. Huh? What do you know? It works. Oh, you want another one? Okay. Okay. Let's go with 39 plus 11. 39 is odd. 11 is odd. That's 50. 50's even. Oh, what do you mean not good enough? Oh, I'm just listing examples. Oh, I don't know what you want. Okay, well, how about the third one? Even plus odd equals odd. Well, how about this one? Let's just come up with an even number. Let's go with 16. And let's add 7. 16 is even. 7 is odd. Well, that's going to be 23. Oh, that's an odd number. Hey, what do you know? It works. Oh, not good enough? Why don't I just come up with one more? Let's go with 28 plus 15. 28 is even. 15 is odd. Well, 28 plus 15, that's 43. Hey, what do you know? Another odd number. Okay, so we got no credit for just listing examples on this question. Not paying attention to the fact that an even number is 2 times n. Well, let's just say n is any real number. We could use a, b, c, d, e, f, g, and so on and so forth. So an even number by definition is 2n. In other words, it's an even number by definition is double another number. Never thought of it that way. You always thought of, it's divisible by 2. Well, you can also look at it as, 6 is 2 times 3. 20 is 2 times 10. 102 is 2 times 51. Whereas an odd number is always written as 2n plus 1, or 2 times any number plus 1. Because an odd number cannot be divisible by 2, you take an even number and you add 1 to it. So what we're going to do is we're going to use this given information to actually do it. So without further ado, I'm going to show you how we use the given to prove it. So let's do this right. Even number plus even number equals even number. Well, again, you could pick any letter, A through Z. I'm going to go with A and B. Why not? I'm boring. So let's say an even number, let's call the first one 2A. And let's call the second even number 2B. Well, can I combine like terms? Well, I know what you're thinking. Like, if this was 2x plus 2x, or 2a plus 2a, then, I would make it 4a. But they're not the same variable. But I'll show you what you technically have been doing all along. I can factor out the 2. If I can factor out the 2, 2 times A is 2A. 2 times B is 2B. Therefore, I've created this multiplication problem right here. All I did was factor out 2. And given this information over here, I don't care what A plus B is equal to. Sorry. I don't care what A plus B is. A plus B could be an even number, A plus B could be an odd number, but I do know that anything doubled becomes an even number. And that is a proof. You notice that I was very confused when I was in college when the professor said you can't just use examples. You have to prove it for all whole numbers that this is true. And I was like, wait, so you want me to do 1 plus 1, 2 plus 2, 3 plus 3, and so on and so forth. Like all the even numbers in the world, I'll be here for, infinity. That doesn't make any sense. But no, you just state facts that any even number can be rewritten as 2 times A, or 2 times B, or 2 times C, and you just go with it. And you see, oh, what can I pull out of this? All right, let's start with, let's do number 2. Odd number plus odd number is even number. Well, remember that an even number is 2 times a letter, 2 times A. So let's just call an odd number 2A plus 1. And let's call a different odd number, let's call it 2B plus 1. So all I'm going to do is just break down the parentheses. All I did here was break down the parentheses. And then I just look at what I'm given. Okay, can I combine like terms anywhere? Yeah. Well, 1 plus 1 is 2. So that gives me 2A plus 2B plus 2. Hey, you know that they all have 2. So why don't I actually factor out the 2? So now I've got A plus B plus 1 in parentheses, and that's all going to get multiplied by 2. So if I factor out the 2, let me get a better pen. There we go. Now I've got the same kind of idea where if I look at A plus B plus 1, I don't care what A plus B plus 1 is. Anything getting doubled creates an even number. And finally, even number plus odd number equals odd number. Well, I'm boring, so I'm going to use A and B. So let's go with 2A for the even number. And let's call the odd number 2B plus 1. Now I'm just going to break down the parentheses. 2A plus 2B plus 1. Well, can I factor anything out from all 3? Well, I can't factor something out from all 3 unless you want to factor out a 1, which doesn't really help me. But I tell you what, I know I can factor something out from 2A and 2B. I'm going to factor out the 2 from A and B. So I factor out the 2, and the same thing arises. I don't care what A plus B is. Anything getting doubled creates an even number. So therefore, 2 times the quantity of a plus b creates an even number. And if I do even plus 1, I always get odd. That's a proof. Now, before I let you go, you guys don't have to. You guys are done taking notes. I just want to leave you with one thing. So, my spring 2010 professor said examples are not proofs. He would tell us, you go outside, the grass is wet. Oh, it must have rained. No, it could have been a sprinkler. It could have been a leak. It could have been anything. Anything could any liquid could make the grass wet. It doesn't necessarily need to come from the sky. So he closed the first class with this: are addition, multiplication, and exponents the same thing? And we all laughed, like, no, are you kidding me? No, addition and multiplication and exponents are completely different. He's like, well, 2 plus 2 is 4. 2 times 2 is 4. And 2 squared is 4. Huh. 2 plus 2, 2 times 2, 2 squared. They're all the same thing. Therefore, a plus b is equal to a times b, which is equal to a to the b power. And we went, no, because let's just say I do 3 and 2. Let's say 3 plus 2 is 5. 3 times 2 is 6. 3 squared is 9. See the difference is, if you want to prove that all things are true, you have to use algebra and logic. If you want to prove that something is not true, all you need is a counterexample, and it fails. So therefore, this doesn't work. So anyway, a bunch of nonsense. But yeah, I just wanted to give you guys a warm-up, just a fun day of what a proof is. And we'll do some trig proofs tomorrow. So tomorrow, you guys need to remember sine, cosine, tangent, cosecant, secant, and cotangent. Okay? Sine, cosine, tangent, cosecant, secant, cotangent. And that's going to help you tomorrow. I'll give you guys a cheat sheet that's going to help you out. All right. Have a good day.